A signal's waveform is a plot of its amplitude over time. In some cases, we're interested in visualizing amplitude versus sample number. In other cases, we want to look at amplitude versus the time in seconds. Therefore, it's necessary to be able to convert from one unit of time to the other, from samples to seconds. First, let's look at visualizing a signal's waveform within a digital audio workstation. Then we'll switch over and look at plotting a signal's waveform in Matlab. In our digital audio workstation, we can visualize a signal's waveform. Here we're plotting the signal's amplitude on the vertical axis versus time on the horizontal axis. We can also switch between different units of time. First, a time in samples. And also a time in seconds. Now let's switch over to Matlab and plot this signal's waveform based on these units of time. Here I'm going to demonstrate how to use Matlab to plot a signal's waveform. As an example, let's say we have a sound file that we'd like to use. I have one that's stored on my computer's hard drive called acousticguitar.wave. I'll use the audio read function to bring it into Matlab. That will create two new variables, one for the actual signal, and then another one, fs here, for the sampling rate. Now we can use the plot function to display our signal. When I run the script, Matlab will open up a new figure window. What's being displayed here is the amplitude of the signal over time, or the value of each element against each element number. In fact, if I zoom in here very closely at the beginning, what's going to happen is our signal actually starts at element number 1. When we are working in our digital audio workstation, and our sound file started at the beginning of our timeline, it was actually the case that it started at sample 0. So what we need to do is tell Matlab the scale that we want to use along the horizontal axis here for time. Initially, we'll put it in units of samples. So in this case, we need to create a new variable. This will be the value over time on the horizontal axis. So this array represents the value over time for horizontal axis. This is going to be t. Instead of starting at 1, we would like t to start at 0. And it's going to be an array that goes all the way up through the length of our signal minus 1. This is because we're going to use t of 0 instead of t starting at 1. T started at 1, it could go all the way up to the length of the signal, but we're adding an extra sample here at the beginning as 0, so we need to take 1 off the end. This way, t and signal will have the same dimensions. Now we can put it in here with our signal and run the script. In this case, what's happened now is we have at the beginning, we're starting at 0 instead of starting at 1. So now we've put it in units of samples along the horizontal axis. Next thing let's do is look at units of seconds. What we're going to do is make use of our signal sampling rate. So here our sampling rate, put in some comments, fs, this has units of samples per second. If we were to look at the sampling period, which is going to be 1 divided by our sampling rate, our units are going to be seconds per sample. So the inverse of our units for our sampling rate. This is our sampling period. Now we can use this to convert our units of time to our other scale. So to begin with, we have units of samples. What we're going to do is multiply this by seconds per sample. So we're going to multiply by our sampling period, which has units of seconds per sample, In this case, samples will cancel with each other and we're left over with units of seconds. Now when we plot t versus our signal, we're able to see along the x-axis that this is going to be about a 7-second long signal. So this is how we can use Matlab to plot a signal's waveform for several different units of time.